Assalamu alaikum. I welcome all of you to the video lecture series. So first of all, let me talk about myself. To my hair, what happened? I just tried to cut it myself because of lockdown, and what happened? The end result is this. So I lost my beautiful hair, but okay, it's okay. It will grow again. But I love this one too. Okay. So now come to the point. Today we will be studying waves. That what are waves and some properties of waves. But a question arises: why waves? Because we have heard that electron in an atom behaves like waves. As you know that electron have dual nature. It can behave like a particle, okay, and it can also behave like a wave. So we are interested, we are chemists, and we are interested in atom, molecules, bonding, etc. That's why we will study the wave behavior. We want to understand the wave behavior of an electron. So don't worry that we will not go into depth of mathematics. I will try my level best to present things pictorially. Okay, so let's come to what are waves. Waves generally are disturbance that moves through some medium. A disturbance that moves through some medium. This is known as wave. This definition or this thing is quite a little bit complicated for the first learners or fresh chemists, but it is the way we need to study it. And it will be clear to you when we go into the depth of, or a little bit depth of the waves, okay? That what they are and how they are represented, okay? You might have seen waves yourself in your everyday life, because most majority you may be watching TV, or you might be doing something else. Suppose you have a stone and you throw it in water or pound on standing water of water which is stationary. Ripple is produced or disturbance is produced and waves are produced. So majority of you may have visited to the beaches, okay, to the beach, and on the beach you may have seen the wave formed. That waves are also formed in an ocean, and they comes toward the beach. So you might have seen that, and if someone hasn't visited the beach, so they might have seen it on the television or etc. So the simple wave look like this. Okay, so let me draw it a little bit narrow here on purpose. Okay, so what is wave? It's a disturbance that moves through some medium. So it's like this. So as I mentioned that in an ocean, when you just look at an ocean and it is calm. From calm mean that if there is no wind blowing, or if you just see a pound of water or an ocean which is calm on that time, from the calm I mean that when no waves are produced. So it looks like, its surface look like this. It's flat, a sort of flat. It go with the curvature of water, but it's look like it seems to be flat. But when waves form, something happens like this. So you may have seen that when the ocean was calm and there was no wave, it was like this black line. Okay. So when the wave began to form, or wave came, the wave came above the normal value, the normal sea level. it comes above, some water come above, and then they go deep inside, even below that normal surface of the water when water was calm, and then again it moves like this. Okay, this is a wave. Another way you can just produce a wave is when you take a rope and you just stretch it, okay, and you just shake it like this. So a wave is again produced, and many of you may have experienced that. If you force it, it will produce a wave. So there are some things or some properties or names or parameters that are associated with the waves. So we need to learn those parameters, okay, to try to understand the electronic motion in an atom. But let me tell you one thing, that is the waves which are formed in a rope or the water wave in an ocean. The electron doesn't behave exactly like those. The electronic waves or the wave formed by an electron while it is revolving in an atom, they are different. But most of the properties of the electronic waves and these simple waves are very similar. So if we understand these properties, we can understand those properties as well. Okay. So let me label something. These are peaks. Okay, these are peak and a peak, and these are depth or valley. Okay. And this is suppose a reference point, which you can say it is, let's say we take it as a 0 because there was no disturbance, or the rope was just stretched, or the sea was calm. You can have this. So let me number it just like +1, and this place is -1. Okay, here it is +1 and it is -1. It's just numbering. Okay. This is -1, this is minus sign. Okay, I'm repeating this because sometimes it is not visible in the camera. Okay, so minus plus, this is 0, this is 0. Okay, so there are some things which need to be understood about waves. Those peaks, they are called as crests. Crest. This is again a peak. You can call it a crest, crest. Okay, and those below, the valleys or the depth, the extreme depths, they are called as troughs. Pardon me for my spellings, okay, because my aim is to convey the science. Okay, sometimes I can, or most of the time, because I'm not native English, so I can make and I will make mistakes in English. Okay, these are called troughs and those are called crests. So these are just names. There are other parameters which are necessary to be understood in order to understand the waves. Okay, the simple waves we need to understand. So those one of them is called as an amplitude. In normal or everyday English, this word is used, the word amplitude. And majority of you might have heard this word, that what actually amplitude is. So amplitude, what is an amplitude in physics or in waves? Okay, it is the maximum displacement from the mean position, or if you want to understand it in a little bit easy language, it is the maximum distance from the mean. So let's say this is the mean. Okay, this is the mean. What is the mean? This black line. So you can say that the mean is when water is stationary, it's calm, it's not producing any waves, or if a rope is just lying there. Okay, so the distance, the maximum distance, not only distance, because here it is at some distance, here it is at some distance, but this is highest distance, here again this is a distance, this is a distance, and this is the highest distance. So the maximum distance from the mean, or the maximum displacement of from a mean, okay, which an oscillation produced, actually it is called as amplitude. It is called amplitude. So here is the maximum, this red line, this thing is maximum. Actually I should write them both of the same size, but as you know that it is very difficult to write everything with the same size. But as you see, this is again, this is downward and that is upward, but this is again displacement, it is a distance. Okay, if it is downward or upward, again this thing is also known as amplitude. It's a maximum displacement here, it's less displacement, and it is maximum or distance or displacement. This is maximum displacement. So those things are called in concept of wave, they are known as the amplitudes. Okay, so now what we learned, we learned that wave are like this. Okay, and there are some labels, some points which are labeled in a wave. The peaks are called as the crests, and the bottoms or the valleys or the depths, they are called as troughs. And the maximum displacement or the distance between the mean, okay, the mean and the mean from the wave from the mean is called as the amplitude. Okay, so let's go ahead, let me introduce another concept. Let's draw the mean. Okay, so before coming to the new thing, we need to compare some amplitudes with each other. Okay, suppose this is one wave. This is the mean, okay, this straight line, and this is another wave. The wave look like the same because both have the three teeths and or the peaks or the valleys are on the same place. Okay, this is length. You can say as length. Okay, or so this has bigger amplitude, this thing is more up, and this is a smaller amplitude, and this wave, it has even smaller amplitude than the other one. So this is a smaller amplitude, medium amplitude, very huge amplitude, and this thing has the largest of all amplitudes. Okay, so amplitude can be different for the same waves under different conditions. Okay, so as I told you that we need to have some other to clear another concept or introduce another concept. As you see that these waves are periodic. Periodic means that they repeat itself in time. With certain time this is repeated, and at that time this thing is repeated. Okay, or this and this, so they repeat itself in time. So another concept is called as a cycle. What is a cycle? in concept of waves. Okay, so again it's just a pair of troughs or a pair of troughs or a pair of crests, but it's again an important thing, because majority or most of the concepts are based on this just word cycle. Okay, so you can find a cycle. How you can find? Suppose this is a crest, this is a crest, a top, and this is a crest. So this is a cycle. Between those two troughs is again a cycle. This from here to here, it is again a cycle. Okay, but the more technical way to find the cycle is, suppose you just come to this place where there is zero amplitude, and amplitude here is 0, because this thing is 0, and it is +1 and it is -1. Okay, and as you know that here, suppose the wave is moving in this way. Okay, in that direction. So the wave is moving in this way. So as you know that this thing is coming down from the mean and going up, and going down and up, and going up and down. So we need to find a point like this in this whole wave, so that will complete one cycle. So if we come to this again, there should be condition. We should go again for a position like this. This position has 0 amplitude, so we can select this one. If we select this one, but because the wave is moving this way, but here the wave is coming downward, the curvature or the wave is coming downward from the mean. But here if we select it, it is moving upward. So this is not the position for the cycle. Now we can have this one, and this is the cycle. As you see, the wave is moving downward, and this is 0 amplitude, and the wave is moving downward. So this is called a cycle. Okay. So what is a cycle? A cycle is an interval. It is just an interval. Okay, you can say that it's an interval, or you can also say that it's a periodic repetition of the same point in a wave. Okay, the immediate periodic repetition of the same point, which is immediately repeated. So this and this are again repeated, because here the wave is moving like this and it is coming down, and it is again coming down. Those points are same. So this thing is called as the cycle. Okay, another concept, but it's called as the cycle. So this thing is a cycle. So if you want to know the cycle, so from here to here you can calculate the distance. So it will become something else. So you may have heard another thing. What is that? It's called as the wavelength. Okay. The wavelength is the distance between two crests or two troughs, or in other words, two same points, or it represents one full wave. Okay, so for an easy ways, from here let's move from the distance from this crest to this crest. It is called as wavelength. Okay, so the wavelength, and it is represented by a specific symbol called as lambda. So this is a wavelength, and from here to here it is again a wavelength. It is one full wave. Okay, so what is a cycle? You can say a cycle is one full oscillation or one full wave. Okay, or you can also say that a cycle is the two same points on a wave. The immediate two same points of a wave is a cycle. But in most of the cases they calculate it from here to here, because the chances of error are very less, because you can have from here to here, and at the same distance is also called as wavelength. But this distance, they say that from between the two crests, the mid of the two crest is called as the wavelength. The mid of the two troughs is called wavelength, and this is a cycle. You can find another cycle in this wave too. Another cycle is, if you select this one, where is the another cycle? From here, this is zero amplitude and it is moving upward, and here is the same position. Okay. And if you want to find another, you need to go. If you want to find for another friend of the black one, you can come here. Okay. From let's look at this from the black point of view. So this is another point, and let me erase the rest of the wave and ignore the red points. Okay, 1, 2, 1, 2, 3, and if you also ignore this point, so you will see something. Okay, so you can calculate it. Let me erase those things that should not disturb you. So it is 1 from here. Okay, this is 1 and this is 2, so it is 2 cycles. Okay, this wave has 2 cycles in it, or there are 2 waves, 2 cycles or 2 waves in this whole wave. This, from here to here, it is composed of 2 cycles or 2 waves, or you can say 2 lambda. Okay, wavelength. Okay, so there are some other parameters of the waves. They are also called as the frequency, the period, and the wave number. Okay, so we need to also explain them. So first let's start and explain the frequency. Frequency is denoted by the symbol F, frequency. Okay, what actually is the frequency? In books you may have studied the definition, and it's very easy. So what a frequency is, the number of waves passing through a point per unit time. Okay, so this seems like a little bit difficult for those who are starting the waves or studying the waves for the first time. Or you can say the number of waves passing through a point per unit time. Okay, or cycles per seconds. It will be clear in a moment. Okay, suppose this is a wave. Okay, this one is a wave. 1, 2, 3 cycles. It has 3 cycles or 3 waves. Okay, 1, 2, 3. This is 3 waves. Okay, so they say that if they passes through a point, okay, in 1 second. Suppose this is a point or a line, and this, as you know, that these waves are moving like this. Okay, if they just move like this, if they move in 1 second, suppose you have 1 second of time and they move like this. Okay, so what is the frequency? So this is the definition of frequency. What is the frequency? Because you have 1 second and these waves passes through in 1 second. These are 3 waves. So you have its frequency is 3 waves per second, or 3 cycles per second. But there is another terminology which is used for it. It is called as hertz. So cycle per second or wave per second is called as hertz. So these waves are, if they passes through this line in 1 second, so what you saw, 3 waves just passed through this line in 1 second, so it is 3 hertz. Okay, as wave, number of waves passing through a point or a line or some place per unit time. So the time is mostly taken in seconds. So number of waves per second is called as frequency. So the wave which you saw, it has a frequency of 3, okay? Because in 1 second, suppose you had 1 second of time and it was 3 waves or 3 cycles per second. So cycle per second, waves per second or 3 cycles per second, it is called as hertz. So it is 3 hertz, capital H and small g. I am writing the small g like big Z, but okay. This 3 hertz, where frequency is determined in hertz, okay, or represented in hertz. So let me show you some other one or two other examples. Suppose this is a point and you have these frequencies. It is, let me tell you, because if it is not clear, so first of all you just need to see it. Okay, this one is 1, 2, 3 hertz, the blue one. Sorry, 3 cycles. This one is 1, 2, 2.5. Sorry, 1.5 from here to here, 1.5, and this is 1 wave. Here you have 1, 2, 3 waves, 1.5 wave, and it has 1 wave. Okay. So as you know, when suppose, let me give you an example. The electromagnetic radiation, or the light which is coming or from the sun to the earth, it has many wavelengths present. Different waves are present, but the light has the same speed. So how can you say that the light has the same speed and they have different frequencies or wavelength? Yes, they have the same speed, and it will be represented, you will understand it by this. Okay, suppose this is a light, and suppose it reaches from sun to earth in 1 second. It takes about 8 minutes, but let's suppose it comes and reaches the earth in 1 second. Okay, this is the sun, and it is here in the sun, and it is the earth. Okay, it just reaches there. So as you see here, there are 3 waves, 1.5 waves and 1 wave, and these are all moving with the same speed. Okay, but frequencies are different and wavelengths are different. So it moves like this to the earth. Okay, suppose it moves from here to here, the whole page is having different wavelengths. Different waves are moving. This is a wave with the 3 cycles, a wave with the 1.5 cycle, and a wave with 1 cycle. So when they all move within 1 second from the sun to the earth, so their speed is the same, but their frequencies are different. Suppose it takes 1 second, so it is 3 hertz, it is 1.5 hertz, and it is 1 hertz. Okay. So there is another term which is called as the period. Okay, and what the period is, it also represents a wave. Okay, it's necessary for the wave. What actually is the period? The time a wave takes to complete 1 cycle. Okay, how long will it take to complete 1 cycle? What was the frequency? The number of waves or the number of cycles, all cycles in a wave passing, the number of cycles passing through a point in 1 second. Okay, here it says that how long will 1 cycle take. It will be clear in a moment to you when we compare it to the frequency. Okay, suppose we have 3 hertz frequency, 3 hertz frequency of some wave. Okay, just like this wave. Suppose you have 1 second of time, and this is a point, and it is 3 cycles or 3 waves. It passes through this line in 1 second. So what happens? It is 3 hertz. Okay, its frequency is 3. So the period is inversely proportional to frequency. So period is equal to 1 by, plus put the values of the this, and you have 0. I think 0.33 is the value, 1/3 of a second. It will be its period. Okay, so these things are also very important. And there is another thing which also represent, or a parameter that represents a wave. Sometimes it is used in infrared spectroscopy. It is called as the wave number. So a very easy definition is that how many waves can be how many waves you can accommodate in certain distance. Okay, let's suppose, it will be clear right now. Suppose you have 1 meter distance. This is not 1 meter, but suppose this is 1 meter distance, and you have those frequencies. This is 1, suppose it is 1, 2, let's increase this to make it a whole number. Okay, 3, it's 3 waves, and this is 1 meter distance. So what will be its wave number? 3 waves, okay, per meter, or 3 waves per meter, or they also write it 3 meters inverse, or 3 meter inverse. Okay, but in infrared spectroscopy the wavelengths are very short, so they use their centimeter. Okay, so suppose that how many waves can be accommodated in 1 centimeter. Okay, so it will again be clear with the same example. Now suppose from here to here this distance is 1 centimeter. It is not 1 centimeter, for sake of understanding we say that it is 1 centimeter. So how many waves this can accommodate? 3 waves of this. So its wave number is 3. Okay, 3 waves per centimeter. It is 1.5 waves per centimeter. It is 1 wave per centimeter. Okay, so let me write it. The above one, the blue one, I can write it for this. The wave number for this, the wave number is 3 waves per centimeter. This one, 1.5 waves per centimeter, and the other one, 1 wave per centimeter. Or they also write it like, suppose I am writing those things. Okay, the 3 waves in wave number term, they write it like this is 3 waves per centimeter, so they write it 3 centimeter inverse, because it is divided by, or you can accommodate 3 waves in 1 centimeter. 1.5 centimeter inverse, or you can accommodate 1.5 cycles in 1 centimeter, or the other one is 1.0 centimeter inverse. Okay, so this is another thing which is also very important for the wave. Okay, so there is another thing which we need to explain about the wave. So it will be explained you will understand it in other type of waves, but here I am trying to make you understand that what this thing is. Okay, there is another thing which is called as, where is the blue marker? I have this red one. Okay, suppose this is a wave. Okay, this is a mean position, and you have a wave like this. Sorry, you have like this wave. Okay, this is a wave. I created a very big mess here. Okay, so suppose this is a wave. What we are talking about? Nodes. Okay, so where there is a zero displacement or zero distance between the mean and the wave, it is called as node. So here it is node, this thing is node, zero amplitude, or you can simply say that where the amplitude of the wave is zero. Node, 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 and a node. Okay, this is a node, this is a node, this is a node, and that is a node. So these things are very important for the understanding of waves. Okay, so let me tell you another thing. Those, when the waves are high frequency, they have more nodes. Okay, yeah, and you just can understand it very easily. Suppose I can, let me draw 4 or 5 waves like this. This is one, this is the second wave, and this is the third wave. Okay, we are just counting nodes. Suppose this is again, let me write it from here, so you should not be confused. Okay, with this thing, you might be considering it a node. Okay, suppose all of them are of the same length. Okay, these are now waves. We are going to calculate the nodes. Forget about the third one. Okay, so here you have one node, two nodes, and 3 nodes. Here you have 1 node, 2 nodes, 3 nodes, 4 nodes, 5 nodes, 6 nodes, 7 nodes, 8 nodes, 9 nodes. This means there are 2 relations. When high frequency, there are more nodes. High energy, because frequency is directly proportional to energy, so when a wave has high frequency, so it has high energy. When a wave has high frequency, it has a large number of nodes. If a wave is high energy, it should have a large number of nodes. You will understand that in electrons. Okay, another thing you might have seen, that the wavelength is again inversely proportional to frequency, or frequency is inversely proportional to wavelength. The bigger the wavelength, the smaller the frequency. Okay, if you have big wavelength, you have small frequency. If you have small wavelength, then you have huge frequency. Suppose this, and again in the wave number concept you can also have this thing, you can understand it. This has lower wave number, this has high wave number. Suppose this is a distance. In the same distance, a large number of waves are accommodated and less number are accommodated, so it has a large wave number, it has a large frequency, it has a large energy, it has a large number of nodes. It has a large wavelength, small frequency, less nodes, less energy. So these are the simple terminologies which are very important to understand the behavior of electrons. But let me tell you one thing. Electrons actually form a waves of a different kind. That is called as a standing wave. These are not a standing wave. They progresses in time and they diminishes, or they can transfer energy from one place to another. But the waves associated with electron, they are standing waves. They don't transfer energy, and we will be discussing that, because after now and almost all the parameters of that one, the stationary waves or these waves, are similar in understanding. So it's just it will not take a long time to understand the waves created by electrons, or the standing waves. And that standing waves, when you understand it, it will be a solution for many problems in the future. Okay, thank you very much.